Hello. Okay, so today we are going to look at the questions and answers, and specifically this session is targeting the production possibility frontier and the opportunity cost. My name is Elias from the University of Lusaka. Let's look at one question on the PPF and then determine whether we need to draw a linear PPF or a concave PPF. Remember, we made a distinction between a concave PPF, which is one that is bulged outward, and a linear PPF, which is a straight line and both are downward sloping. And these are the two types of PPFs that we are going to focus on in the principles of microeconomics, which is the introductory course to microeconomics. Let's look at the question and then answer the question, the parts that will follow. Okay, so consider a table below that shows the production possibility schedule for Lukanga Republic. Now we have this production possibility schedule here. We see that we have two types of products that are being produced. We have guns and butter measured in kgs. And then we have 5 options: option A, option B, option C, option D, and option E. And from these options, it's up to the nation to determine at what level or which option it will pick for it to be able to produce either butter or guns, or both butter and guns. Now, from this production possibility schedule, we are able to see the structure of the PPF even before we draw it. But let's see what questions we need to answer in this part. The first part is asking us to draw the production possibility frontier, which is the PPF for Lukanga, clearly showing the points A to E, meaning that we need to draw this PPF and show these points on the production possibility frontier that we will draw. The second question wants us to find the opportunity cost of producing 5 guns. So after drawing our PPF, we will now be able to answer this question. We can also answer the questions from the schedule, but I want us to get used to using the production possibility curve or frontier in answering such questions. The other question, which is part 3, wants us to find the opportunity cost of producing 9 guns. And the fourth part wants us to find the marginal opportunity cost of producing the 9th gun. Okay, then the fifth part is asking us the significance of the shape of your PPF, or the significance of the shape of the PPF drawn in part 1. And in part 1, it was a part where we were required to draw the production possibility frontier showing the points A to E. Part 6 says, what is the significance of the downward sloping production possibility frontier? Okay. Then part 7 wants us to find the opportunity cost of producing 14 kgs of butter. In part 8, we are required to find the marginal opportunity cost of producing 14 kgs of butter, producing the 14th kg of butter. And in part 9, we are asked why the answers in part 7 and part 8 are different. Now, I'm going to show you how we can answer these questions using the production possibility frontier. But maybe before we do that, you can pause this video and try to answer these questions on your own, and then later on you can replay to compare your solutions against the solutions that I will present in this video. So let's answer these questions. So the first part wants us to draw the PPF for Lukanga, clearly showing points A to E. Now, before doing that, we need to know whether the PPF we are going to draw is concave to the origin, or it's a PPF that is linear and downward sloping. In doing so, remember we are using freehand, so there will be no graph papers needed in drawing such a PPF. So using freehand, you need to look at the numbers or look at the gaps. Let's start with the gun. In the production of the guns, we see that with option A, we are producing 0 guns. With option B, we are producing 2 guns, meaning that the difference between the two options is 2. In option C, we are producing 5 guns. The difference between option B and option C is 3. In option D, we are producing 9 guns, meaning that the difference between option C and option D is 4. And in option E, we are producing 10 guns, showing that the difference between option D and option E is 10. So we see that clearly the gaps here are not consistent. We start with a gap of 2, we go to gap of 3, gap of 4, and back to gap of 1. Meaning that with this kind of a presentation, we already know that our PPF, if we are using freehand, will not be a straight line. It will be concave, given that we are only looking at 2 types, a linear and a concave. Further, we may also want to examine the gaps in options between the options for butter. In option A, we are producing 20 kgs of butter, while in option B, we are producing 18 kgs of butter, showing a gap of 2. When we go to option C, we see that the gap between option B and option C is 4. And if we go to option D, the gap between option C and option D is 8. And then down from D to E, we see that the gap becomes 6. So which also there confirms that indeed, the kind of a PPF needed here is not a linear PPF, but a concave PPF. Let's draw the PPF, since we are required to draw the PPF for Lukanga, clearly showing the points and that we are using freehand. Now, in answering this question, look at this question carefully. You will see that we are not told where we are going to put guns and where we are going to put butter, whether it's a vertical axis or the horizontal axis. With this, it's up to you to determine where you want to put your guns and where you want to put your butter. In this presentation, I'm going to use the vertical axis to represent guns and the horizontal axis to represent butter. So I have on my vertical axis there, guns, and on my horizontal axis, I've put butter measured in kgs. Now, before we produce anything, production will always start first from the origin as you are making the plans of what you are going to produce. How many guns you will produce, how many kgs of butter you will produce. So with that, we put 0 as the origin because we are now planning at that point where we have produced nothing. The other thing we need to do, since we're using freehand, and that we know from the structure of the production possibility schedule, that we are drawing a concave PPF. In freehand, it will be easier for you to first draw the curve so that you show how this PPF will look like, and then fix these numbers since you already know that this PPF is concave and there is no need for you to be highly accurate in presenting the numbers. What is important is that you plot these numbers and that they make sense as you are moving up from 0 to the intercept on the gun axis and as you move from 0 to the intercept on the butter axis. So to make the presentation simple, we are also going to fix the maximum values. We know that with guns, when we produce 0 kgs of butter, we are producing 10 guns, meaning that on the intercept here, we will have 10 guns being produced. And if we produce 0 guns, meaning that we are looking at the horizontal axis, we are producing 20 kgs of butter. So again, we can fix that the maximum amount of butter we can produce is 20 kgs. Now, these 2 points, we see that on the butter axis, we see that the intercept is 20, and at that intercept, we have the first option, which is option A. And if we go up, when we produce 0 kgs of butter, we are producing 10 guns. And on that axis, we have on that intercept option E. So these are the 2 extremes that we have in our construction of the production possibility frontier. Next, we may want to start drawing, putting the middle parts, the options. Now, the easier one to work with here, in this presentation, we're going to use the guns, which are on the vertical axis. So we'll put these numbers at least trying to be equidistant as much as we can to the best of our visual aid. Where we can't, still, there's no need to leave it out. We can still put those numbers and then use those values to find the corresponding beta values in kgs. So let's fix those numbers. So we have the numbers 2, 5, and 9. And to the best of the presentation, probably we can assume that indeed 5 can be somewhere there in the middle and 9 is close to 10. Now, to fix these other options, we start from the vertical axis. Let's start with the 2 here. So if I know that for me to produce 2 guns, these 2 guns will correspond with 18 kgs of butter. It means that I will have to draw a line, extend it all the way from 2 to the production possibility curve or frontier. And where it's hitting the PPF, I draw a line coming down. So this line, we see that it's corresponding with 18 kgs of butter. And that is option B, so we can indicate our option B there. Next, we have option C. With option C, we are seeing that we are producing 5 guns and 14 kgs of butter. So again, we're going to draw a line from 5 kgs all the way to the production possibility frontier. And where it hits the production possibility frontier, we extend that line downward. So we draw a line that is joining the frontier and the horizontal axis. And at that point, we see that when Lukanga Republic produces 5 guns, it's also producing 14 kgs of butter. And this is option C. Lastly, we have option D, and with option D, we see that Lukanga is producing 9 guns with 6 kgs of butter. So from 9 guns on the vertical axis, we draw a line joining the vertical axis and the production possibility curve. And where it hits the production possibility curve, we draw a line joining the production possibility curve and the horizontal axis. And that we see that we are producing 6 kgs of butter. And that is point D. Well, this is the production possibility frontier that we were required to draw. And we can see that this production possibility frontier is concave to the origin, and that all the points, all the options A, B, C, D, and E are reflected on this PPF. Now, let's answer the next question. The next question wants us to find the opportunity cost of producing 5 guns. Now, to answer this question, you will need that production possibility frontier that we drew in part 1. So let's bring that production possibility frontier here and then answer the part where we need to find the opportunity cost. Okay, so if we are to find the opportunity cost of 5 guns, we look at, remember, production starts from the origin. So we look at the corresponding point here. So if we were to allocate all the resources in the production of guns, we were going to produce 10 guns. And if we allocate all the resources to the production of butter, we are going to produce 20 kgs of butter. Now, suppose that we've allocated all the resources in the production of butter and that we are producing 20 kgs of butter. What is the opportunity cost of producing 5 guns? In other words, the question is asking us to determine how many kgs of butter do we need to give up for us to be able to produce 5 guns. And we see that if we are to find that point where 5 guns are, this point is corresponding with 14 kgs of butter, meaning that we are giving up this amount here from 14 all the way up to 20 here. This part is being given up. We are moving from this point, we start going backwards until we find a point that corresponds with 5 guns, and that is point 14. So the difference between the maximum that we can produce if we allocate all our resources to the production of butter and the amount that we are now producing, given that we've added 5 guns, that amount that difference is giving us the opportunity cost of producing 5 guns. Therefore, if we calculate the difference here, we are getting 6. And thus, we conclude that the opportunity cost of 5 guns is 6 kgs of butter. So the opportunity cost of 5 guns is 6 kgs of butter. Let's answer the third part. The third part wants us to find the opportunity cost of producing 9 guns. Again, for us to answer this question, we will need our production possibility frontier. From here, remember we said that production will start from the origin, and that if you allocate all your resources in the production of guns, you will produce 10 guns, which is the maximum. And if you allocate all the resources in the production of butter, you produce 20 kgs of butter, meaning that's 0 of guns. So now, we are starting from this point here, where we've allocated all our resources in the production of butter. We want to determine how many units or how many kgs of butter we need to give up for us to be able to produce 9 kgs, 9 guns. If you go to the PPF here, you will see that this 9 guns is corresponding with 6 kgs of butter. This is point D. So what we are therefore saying is that we need to know how many kgs of butter are we giving up from 20, the maximum, for us to come and reach 6 here. How many kgs of butter have we given up? So in doing so, we simply subtract 20 minus 6. So we are looking at this region here. So we are moving from 20, going down as we are moving up the frontier, increasing the production of guns until we reach 9 guns, which is point D. So we are moving up the PPF, going all the way until we find 9 guns, which is corresponding with 6 kgs of butter. So this difference here has been given up to allow for the production of 9 guns. So therefore, 20 minus 6 will give us 14. And therefore, we conclude that the opportunity cost of producing 9 guns will be 14 kgs of butter. Great. Let's answer the fourth part. The fourth part is asking us to find the marginal opportunity cost of producing the 9th gun. This should be 9th gun. So get rid of this part here so that this reads 9th gun. Okay, so we're saying what is the marginal opportunity cost of producing the 9th gun. Now, to find the marginal opportunity cost of producing the 9th gun, we are taking note that there is also the 8th gun, which is allowing us to move from the 8th to the 9th gun. And to answer this question, we'll need our production possibility frontier that we drew in part 1. And from here, we see that the numbers are not in a series or in a sequence of ones, but they are skipping, which means that we need to use the formula in order to find the marginal opportunity cost. And that formula tells us that marginal opportunity cost is the ratio of the change in the foregone to the change in the gain. Now, the foregone here represents the amount that you are going to give up to produce a unit. And the change in the gain here is measuring that additional unit that you will have to produce. Now, given that the numbers here are not in a sequence, or that the numbers here are not in a sequence of 1, or they are skipping, and so is the case with the horizontal axis, we'll need to look at the 2 points, the immediate previous point to the 9th gun. So we see that the 9th gun here is at point D, corresponding to 6 here. And therefore, the point before, immediately to this point D, is point C here. So it means that we're going to use point C and point D to find the marginal opportunity cost. Take note, Do not use point E here, because point E will be talking about the 10th gun. So because we are looking at the 9th gun, then we take note that before the 9th, we should have hit the 8th. But 8th is not represented here, is not displayed. Therefore, we go down all the way to the next point that we have on our PPF, and that next point, immediate point, is showing us 5 guns and 14 kgs of butter. So we are going to use 9 guns against 6 kgs of butter and 5 guns against 14 kgs of butter. So in this our formula then, the change in the foregone is the amount that we are giving up. For us to hit point D, remember we're coming from 5 going up to 9, meaning that we're moving from point C going up to point D. The foregone is the amount that we are giving up in order to move from point C to point D. And if you follow through this production possibility schedule, it will show you that if at point C you have 14 kgs of butter, as you are moving up, going to point D, you'll be losing the kgs of butter in order to add the guns, such that as you are hitting point D, you will have lost 14 minus 6, which is 8 kgs of butter. So therefore, the foregone in this case becomes 8 kgs of butter, or simply we just put 8. Now, as you have moved from point C to point D, take note, you have lost 8 kgs of butter, but you were adding on guns, because at point C, you are producing 5 guns, while at point D, where you are landing, you are producing 9 guns. Therefore, the difference between 9 and 5 will give you the change in the gain. And that, you'll see that 9 minus 5 will give us 4. So we see that we are now getting the ratio of 8/4. And when you simplify this, you're going to get 2 kgs of butter. Therefore, the marginal opportunity cost of producing the 9th gun is 2 kgs of butter. Which means that for us to add an additional unit or an additional gun to hit the 9th gun, we need to give up 2 kgs of butter. Remember also that when measuring opportunity cost, we use the units of the foregone. So in this case, we are giving up butter, and therefore we are saying opportunity cost will be 2, but the units we are using are kgs of butter, since we are giving up the butter. If we were giving up guns, then we'll have measured the opportunity cost using guns. But here, we are giving up butter, so the marginal opportunity cost of the 9th gun is 2 kgs of butter. Let's answer the next question. What is the significance of the shape of your PPF drawn in one above? So now to answer this question, you need to have a look at that PPF that you drew. This is the PPF that we drew in part 1. And when we look at this PPF, we are seeing that this PPF is concave to the origin. So the significance, therefore, of this shape, of this concave shape, is to show, or because of the presence of increasing opportunity cost. As you add more and more guns, you will see that for each additional gun added to the production, you will be giving up ever increasing amount of butter in kgs. And for each kg of butter added to the production, you'll be giving up ever increasing amounts of guns. So we are saying that the significance, therefore, of the shape of the PPF is that it reflects increasing opportunity cost. As an explanation, we say that to produce an additional gun, we require giving up increasing amounts of butter in kg. And similarly, to produce an additional kg of butter, we require giving up increasing amounts of guns. So this gives us the reason or the significance of this shape of the production possibility frontier that we drew in part 1. The other part wants us to state or to explain the significance of the downward sloping PPF. So now, again, to answer this question, we need to look at the production possibility frontier. We are seeing that this production possibility frontier indeed is downward sloping. As you are moving from point E to point D, you'll be losing on guns but gaining on butter. As you move from point D to point C again, we see further that we are losing on guns to gain on butter. As we move from point C to point D, we are losing on guns to gain on butter. And as we move from point B to point A, we are further losing on guns to gain on butter. And therefore, we see that the significance of this downward sloping PPF is that it is showing us that there is trade-off in the construction in this PPF. So it reflects trade-off. That is, to produce more of guns, we need to reduce on the production of butter. And to produce more of butter, we need to reduce on the production of guns. So this downward sloping PPF tells us that in our production options, we will face trade-off. The other part wants us to find the opportunity cost of producing 14 kgs of butter. Now, to answer this question, we again need to have sight on either our production possibility schedule or our production possibility frontier that we drew in part 1. Let's use our production possibility frontier. Now from here, we're seeing that 14 kgs of butter is here, and this is corresponding to point C, where we are producing 5 guns. Remember, as before, if we allocate all our resources in the production of butter, we'll produce 20 kgs of butter and 0 of guns. And if we get all our resources to the production of guns, we'll be able to produce 10 guns and 0 kgs of butter. So now we want to know if we've allocated all our resources in the production of guns and that we're producing 10 guns. How many units of guns do we need to give up for us to add 14 kgs of butter? If we allocate all our resources in the production of guns, how many guns do we need to give up? How much resources do we need to draw away from the production of guns and take to the production of butter, so that we now have 14 kgs of butter and only remain with these 5 kgs of 5 guns? To do that, we look at the corresponding point. So we see that this 14 kgs of butter being talked about here is corresponding with 5 guns. So for us to find the opportunity cost, we are going to move from 10 and move down all the way to the new level of production. So and see how many we will have given up for us to be able to produce 14 kgs. And clearly we see that we are giving up 5 guns in order to produce 14 kgs of butter. So therefore, the opportunity cost of 14 kgs of butter is 5 guns. Remember, opportunity cost is measured in terms of the foregone, or using the units of the foregone. Here, we want to produce butter, so we want to know how many units of guns do we need to give up in order to produce 14 kgs of butter. So we are saying that we need to give up 5 guns for us to be able to produce 14 kgs of butter. Let's look at part 8. Find the marginal opportunity cost of producing the 14th kg of butter. Now remember, we said that if you are looking at marginal, we are talking about an additional. So we want to know how many units of guns, or how many guns do we need to give up in order to allow for the production of an additional kg of butter to reach the 14th kg of butter. And to do this, we need to have sight on either our production possibility schedule or the production possibility frontier. In this illustration, or in this session, I'll use the production possibility frontier. The 14th kg is here, so we want to know, before the 14th kg, where were we if we are to add an additional kg? Clearly, we see that if we are talking about the 14th kg, then probably we know that we are moving from the 13th kg. But from this illustration here, we don't have the 13th kg. What we have nearest to 14 is the 60th kg. So it means that from here again, we will have to use the formula for us to be able to find that marginal opportunity cost. And at the 14th kg, if you're producing the 14th kg, 14 kgs of butter corresponds to 5 gallons. And the immediate level before 14, we said will be 6, the 6th kg, and this corresponds to 9 gallons. And the corresponding points are C and D respectively. So in this case, we are moving from point D going down to point C, because only moving in this direction are we seeing ourselves adding on butter. So therefore, the immediate point before point C is point D. So we are moving in this direction to add the 14th kg of butter. Do not look at point C and B, because once you go to point B, then you'll be looking at the 18th kg of butter. So if we're talking about 14th, we need to look at the point before the 14th, which from this diagram, what we can see is the 6th. So if we are to find the marginal opportunity cost, this will be given by the ratio of the change in the foregone divided by the change in the gain. As earlier mentioned, the foregone here talks about the amount of guns that we need to give up for us to be able to produce an additional unit kg of butter. And the gain here talks about the amount of butter that we are going to produce. So if I'm moving from point D to point C, we see that I'm adding on this part here, from point D to point C, I'm giving up 4 guns in order to produce 8 kgs of butter. So the foregone will be 4, while the gain will be 8. And if I get that ratio clearly, it will give me 0.5 guns, or approximately 1 gun, because you can't have half a gun. So we approximate it, we round off to the nearest whole number, and we get 1 gun. Therefore, the marginal opportunity cost of producing the 14th kg of butter is 1 gun. The last part wants us to explain why the answers in part 7 and part 8 are different. We see that from this production possibility frontier, we noted that from part 7, we were required to find the total opportunity cost, and we found that the total opportunity cost was 5 guns. While in part 8, we were required to find the marginal opportunity cost of the 14th gun, where we found approximately 1 gun. So therefore, we conclude that the answers are not the same, because in part 7, we are looking at the total amount of guns needed to be given up so that we produce a total of 14 kgs of butter. While in part 8, we are looking at the amount of guns needed to be given up so that we produce just 1 kg of butter to reach the 14 kg of butter. So thank you very much for watching. I hope this was helpful. Please make sure you subscribe to the channel if you haven't subscribed, so that you get automated updates on all videos that will be uploaded on YouTube. I'll be doing more examples, and the next example that we're going to have, we'll look at the constant opportunity cost, and then we're going to answer these similar questions to see the difference between the increasing opportunity cost PPF and that for constant opportunity cost. Bye-bye.